Hello, my learners. How are you all? I hope you all are doing great and you all have gone through that structural isomers and stereoisomers video by now. And since we have nailed it, we are prepared. So let's see how to apply that learning into the questions, how the questions comes and how to comprehend them. So let's start from the very first question. How many structural isomers exist for C4H10, right? So let's make the structure first. So I will make 4 carbon. I'm not making hydrogens, right? All these are hydrogens. This is my first format. What else I can do now? I can take this particular carbon and put it in the middle, right? If you remember, we did the same question in the explanation also. Yeah. So that's my second case. So I have 1 and 2. How many isomers? 2 isomers. That's why the answer is 2. Right? These are the common names. You need not to think on this particular common name. We are just asked about the IUPAC naming followed by the number of isomers. Yeah. Moving ahead to next. How many structural isomers for C3H6Br2 there? In the comment box, I am looking forward to tell me how many structural isomers are there. So please let me know how many are there. Now we have to make it for C3H6Br2. So let's make the structure first. 3 carbon. I have to attach 2 bromine. Since they have not specified anywhere, I will attach like this. Br and let's say another Br over here. Then 1, 2, 3, 4, 5, 6 hydrogen. Correct? Now I have to make structural isomers. I have functional group attached to it. So which isomer am I talking about over here? It's positional isomer, right? So what I will do, I will change the position of Br. How can I change the position of Br? There are just 3 carbons. How will you change it? Can I place? Yeah. First case, I placed it at carbon number 1, carbon number 2. Now I placed it at first carbon. I have one more way of doing that. Is it? I can place it at like this. Yeah. Oh. I will again call it 1, 1 dibromo like this, 1, 1 dibromo. So this will not be counted as a separate isomer. What I can do is I can play it both at the second one. Right? These are all hydrogens. So I have, what is this? This is 1, 2 dibromo propane. What is this? 1, 1 dibromo propane. Right? Then you have 2, 2 dibromo propane. Is there any other possibility there? One more. I can place it at first and I can place it at the last. It's over here and at the last. Right? So what will I call this particular name? This will be 1, 3 dibromo propane. Please keep one thing in mind. When you are placing at the same carbon, students do 1 dibromo. Please know, number of times it is coming, you have to write down that particular number. No matter it is coming on the same carbon. Right? So please mention. So we have 1, 1 dibromo, 1, 2 we can have, 1, 3 we can have, yeah, 2, 2 we can have, 2 bromopropyl bromide we can have. What is this 2 brom? Yes, moving ahead to the next one, which is functional group isomers. Functional group of CH3COH, remember? Which functional group is this? Carboxylic. Carboxylic can get converted to what? Which one? Ester, right. So which one is a ester? Is this a ester? One oxygen. Is this a ester? Yeah, two oxygen. This ester? No. This ester? No. So the answer becomes B, right? Then this is CH3COH, so that's why the name comes methyl methanoate. Yeah? Tell me in the chat box, aldehyde get converted to what? And ketone was getting converted to what? And was getting converted to what? And alcohol was getting converted to what? Next stereoisomer is butane to ol. Which compound exists stereoisomeres? So stereoisomeres, remember, optical isomeres or the geometrical isomeres. For a geometrical, you should have a double bond present between the carbons, and for optical, you should have an optical active carbon, which is called chirality, optical activity, right? Okay, on this note, the two mirror images that we are getting of the optical isomers, they are basically called as enantiomers, and the mixture, because we are getting 50-50% both the mirror images, that mixture is called as racemic mixture, and the process is racemization. So you have something called as racemic mixture, then you have racemization, and you have something called as enantiomers. So what are those enantiomers? These are those mirror images, right? You call both the mirror images as enantiomers. Mirror images were those that you call them that they are rotating clockwise or anti-clockwise, right? So both the enantiomers So both the enantiomers exist as 50-50% ratio. That process is racemic mixture. That mixture is basically called as racemic mixture, and the process of obtaining that is racemization. How do it obtain? If you remember, we discussed that when a compound is thrown with a plain polarized light that is coming from a polarimeter, it rotates the molecule. In which direction it is rotating depends that in which direction, on which end you have the bulky group attached, right? Okay, so let's see CH3, CH2, CHO. Can you see a double bond or an optical carbon over here? This is having all three hydrogen, this one. This is having two hydrogen. This is having one hydrogen, two oxygen. So A is out of the picture. Coming to B, CH3CO, CH3. It is having a double bond, but a double bond with oxygen. So again, this is out of the picture. And rest of the two carbons are having three hydrogens. Coming to the C part, CH3, CH, CH3 whole twice. So this molecule is like this. All three same. So this is also out of picture. Anyways, you are left out with option D only, but let's see why and how. Let's make this structure CH3. Then to the carbon, you have one side H, OH, and then CH2, CH3, right? So if you see, you have one side H, one side CH3, one side OH, one side CH2, CH3. So this particular carbon becomes your optically active carbon, right? And that carbon is called as a chiral center. Property is called as chirality, and you represent this by an asterisk with a star. Yes or no? So that's why this is the answer. And it shows which isomers? Optical isomers. Right? Next, cis-trans dicyclochlorobutane. Now first let's draw cyclobutane. How does a cyclobutane look like? Cyclo means a closed compound. Bute means 4 carbon. A compound made up of 4 carbon, right? 4 lines. So each point represents what? Each point represents 1 carbon, right? If you remember, this looks like something as a skeletal diagram. Now, I have chlorine attached. At where? First and third. I can number it anywhere, right? I can start numbering it from anywhere. So let's say I can start number the compound anywhere because they have not specified. So let's say I started it from here. 1, 2, 3, 4. So my bromine is attached to this carbon and this carbon, right? Now this is looking like a square. These are the two parallel sides. And if you make a transversal, it is like this, right? So transversal has one end up, one end down. Over here, I made both up. So when both are up, it will be a cis form. That means if I have to make a transform, I will make the compound and I will attach bromine both downside. So you can note it down that for cis form in cyclo compounds, one has to be up and other has to be down. Right? Sorry, this is not cis, this is trans format. They're lying along the transversal. Whereas for the cis format, both has to be upside. You also call this as wedge bond. Fine, if you remember, no need to take a stress because it is not going to be evaluated. Just need to keep in mind that when they ask you to create a cis or a transform of cyclo compounds, so for a cis format, keep both the things upside, and for a trans format, one up and one down. And keep this would help you in keeping that in mind. Yeah. Perfect. Moving ahead to the last question, which is pent-to-ene. You have to do easy format. Remember easy? Priority section something. Okay, so let's make pent-to-ene. Pent is 5. Right? This is carbon pent. Second carbon double bond. Right? Now let's complete the valency. So this is CH3. This is only having one H, and this is CH2, this is CH3. So you are having a double bond along this. C double bond C. You have both the carbon attached with 1 hydrogen. And this carbon is attached to C2H5 group. And this is attached to CH3 group. Okay, why it is not showing cis and trans form? Because it is having 3 different groups. 1, 2, and 3. For cis and trans, it has to have max to max 2, right? If you have not seen, please go back to the video and check it out. We will get back to it. So this will show E and Z format and not the cis and trans. So for E and Z, we check the priority. Priority comes from the atomic number. So over here, H and C2H5, which one have the priority? This has the priority. HNCH3, which has the priority, this has the priority. Both priorities on one end becomes your Z form. And priorities along the transversal becomes your E form. Yes. Any questions, any doubts? Okay, if you remember that cis format will have more boiling point and more high amount of boiling point because of the strong dipole-dipole interactions. And you are going to tell me in the chat box that what was the keyword I told you for a trans format, that why trans is not having high melting point or a boiling point. We say that something is canceling out something. So you just tell me that keyword, what I emphasize in the session. If you have not seen, please go back to that particular video, check it out. You will get back to your answers, right? If you have not checked out, it's a separate that how the questions will be assessed and how the topic will be assessed in the examination. Let's meet in the next video. We'll stop it over here and we'll quickly meet in the next video, which is of organic reactions. We'll start with mechanism in the next reaction videos. So stay tuned, be updated, keep practicing, and let's rock it. Till then, take care and have a good day. Bye-bye.